All right, this one's going to be a doozy. Find the other trig values if cotangent of theta equals negative root 7 and sine theta is greater than 0. In other words, sine is positive. So let's do this. Let's make ourselves a little fake coordinate plane and remind ourselves where sine is positive. Sine is positive up here and up here. Now, if my job is to find the other trig values, it's going to matter about everything else too. So while I'm at it, I care about sine being negative and sinus negative down there. Sinus negative sounds like I'm getting over a cold. So cotangent is negative root 7. Again, I care about positives and negatives everywhere because if my job is to find the other 7 trig values, if that's negative, I'm going to have to deal with negative values all over the place. So let's find out where cosine is negative. Cosine's negative here on the left and positive here on the right. Now, how is this going to help me with the others, like tangent and cotangent? Well, sine divided by cosine's tangent. Its reciprocal is cotangent. I don't know if I said that right. Sine over cosine's tangent. Its reciprocal is cotangent. I'm just giving it a second shot in case I misspoke earlier. But, that's going to help out here. Now, what I also need to deal with is I have to find missing pieces. I have to find sine, cosine, tangent. That's going to require knowledge of SOHCAHTOA. Why I wrote it out incorrectly, I don't know. It's been a long week. SOHCAHTOA. Okay. Now, the first thing I have to do is I have to break down the fact that cotangent of theta is negative root 7. So if I'm supposed to find sine and cosine and tangent and its reciprocals, I care about information about its opposite, hypotenuse. I care about everything, every single part about a right triangle. So I'm making this fake arbitrary right triangle here so I can gather as much information as I have. Okay. Cotangent theta comes from the fact that tangent is opposite over adjacent, which means cotangent, its reciprocal, is going to be adjacent over opposite. Okay, I know that cotangent is negative root 7. I'm not going to worry about the negatives right now when I want to put pieces on a triangle because you can't have a negative length. So I'm going to write that it's root 7 over 1. So according to this, if this is theta, and it doesn't matter which one theta is. If you're wondering, well, which one should I call it? Doesn't matter at all. If I have theta, according to what I just said, the adjacent side is going to be root 7, and the opposite side is going to be 1. That leaves me with the hypotenuse, which I'm going to call C. Why? Well, in order for me to find C, I got to use the old Pythagorean theorem. So what color haven't I used yet? Let's do purple. It's going to be a rainbow when we're done. A squared plus B squared equals C squared, right? You can be my A, you can be my B, and C has to be just C. 1 squared is 1. Root 7 squared is 7. That's going to equal C squared. Let's bring it up here so I leave myself plenty of space for my answers. 1 plus 8. 1 plus 7 is 8. That equals C squared. The square root of 8 is going to be C. All right. Now, if C is the square root of 8, that means I should be able to look at that and be like, wait a minute, can I go a little bit further? Yeah, I can. 8 is 2 times 2 times 2, which means if you rip out a pair of 2s, C is actually this. So my hypotenuse is root 2. My hypotenuse is 2 root 2, pardon me. My adjacent is root 7, and my opposite is 1. Now I have enough information to put all this together. So I want to find what sine theta is. An angel just got its wings. What cos theta is, and what tangent theta is. I also need to find out what its reciprocal cosecant theta is, what secant theta is, the reciprocal of cosine, and I already have u, so I am 1/6 of my way done. Hooray! Now listen carefully to how I'm going to proceed from here on out. Let's deal with the numbers, and then when I'm done, we'll deal with what's negative and what's positive. Let me repeat myself. Let's deal with the numbers, and then when we're done that, let's deal with what's positive or negative. Okay? Sine is opposite over hypotenuse, which means 1 over 2 root 2. Immediately, we realize this ain't good. You can't have root 2 on the bottom. So if we multiply the top and the bottom by root 2 over root 2, that leaves us with 1 times root 2 over 2 times root 2 squared, which is 4. Okay. Cosecant is going to be the reciprocal of this, which is, if I'm not going to look at the answer, I'm going to look at the original, which is going to be 2 root 2 over 1. Okay, so I'm half done. Well, not really, because I have negatives and positives to deal with. Cosine is adjacent over hypotenuse. Cosine is adjacent root 7 over hypotenuse, which is 2 root 2. Let's multiply the top and the bottom by 2 in square roots over root 2. And that gives me root 14 on the top. 2 times root 2 times root 2 again, I already know, is going to be 4. Secant theta is the reciprocal of this, but I'm not going to set it up that way. I'm just going to write out the fact that if cosine is adjacent over hypotenuse, then this is going to be hypotenuse over adjacent. So I have 2 root 2 over, root 7. Multiply the top and the bottom by root 7 over root 7. That gives me 2 root 14 over root 7 times root 7 is 7. Last but not least, if my cotangent is negative root 7, okay, I'm not worrying about negatives right now. I already said that. Let's not worry about negatives. This becomes 1 over root 7 times the top and the bottom by root 7 over root 7, and that gives me root 7 over 7. Now, last but not least, I need to apply my negatives. Okay. All of this stuff, first off, cotangent is negative. Okay. Sine is positive, which tells me that this stuff, which tells me that the original problem, if cotangent is negative and sine is positive, cotangent is negative in 2 spots, here and here. So if sine is positive and cotangent is negative, then everybody lives in the second quadrant, which is why I drew this picture. So in the second quadrant, sine is positive, leave this positive, which means cosecant is going to remain positive. In the second quadrant, cosine is negative, so make this negative, which means secant is going to be negative. Doesn't look pretty, but I'm making it red. I already know that cotangent is negative, so tangent's going to be negative. But if you need further proof, in the second quadrant, sine over cosine is going to be positive over negative, which is negative. There you have it. So to put this all together, even though it looks a little bit sloppy, I have all 6 of my trig functions. where sine and cosecant are positive, cosine and secant are negative, tangent and cotangent are negative. Also, when I figured things out, I had to make sure that I didn't have any square roots on the bottom. And there we have it. Okay. Very involved problem, took a lot of time, but that's to be expected with guys like these. And also keep in mind, didn't use a calculator. So if you had a calculator, life would be a lot easier, but then you wouldn't have exact values. I didn't ask for that, but I assumed because I created the problem. Okay? Thanks for watching.